Well, good afternoon. I'm Bash Nola. I'm privileged to be your moderator for this panel on distributed generation, its growth, and its effect on customer and customer choice. I don't know about you, but up to now, this has been absolutely wow, and I hope you agree. We're in the home stretch, and so we'd like to get started. We have a very distinguished panel for you today to talk about distributed generation. Mr. Mark Duda, President of the Hawaii PV Coalition and founder of a major developer in solar PV. Followed by Matt McNeff, manager of the engineering department for Maui Electric. Again, followed by Dan Gerard, key director of SNC Electric and their renewable energy and customer storage division. And last but not least, Mr. Rick Richelieu, who is the director of HNEI. We'd like to get started and have Mark kick us off. And the idea of DG from a growth perspective and a developer's perspective is, I think, indicative of the fact that we here in Hawaii have led the nation and still continues to lead the nation in the development of rooftop solar. Rooftop solar presents an interesting challenge not only for the developers and the customers, but also for the utilities, added by the fact that we've got opportunities for enhancement of distributed generation and rooftop solar with the introduction of batteries. And the fact that we can take and then take the next leap and go to the creation of microgrids. What is a microgrid? Well, we're going to find out, and how they will enable us to potentially increase penetration of solar generation and become a more viable system resource. So with that, let's get started. Mark, it's all yours.
Thanks, Bash. Can people hear me? It's not clear where the microphone is.
Right now.
Oh, okay. So, is this advancing? There we go. All right. So, I guess I'm speaking here today, I would say not as a solar contractor or solar advocate, but maybe as a DG contractor, DG advocate, but as a DG understander. I think there's probably not actually a ton of people who understand DG all that well in the room today, and it's because we're just that many levels removed from what's actually going on out there where the rubber really meets the road. I myself feel several degrees removed from it. Even within our own companies, it's actually the sales team talking to the customers, which I certainly don't do every day. But when you get, levels above that, you get to my level at the company and you get into the policy-making process, you're really, really, really far removed from what the customer is actually saying and thinking. And I applaud Jeannie's work to try to understand that. That's the best effort I've seen at someone able to do that and to bring it to a broad audience from a survey perspective. But nonetheless, something similar to that is happening every day with all the solar salespeople and project developers out there. And it is radically different from the way that it's conceptualized in policymaking discussions. So that's the perspective I'm trying to enrich this discussion with. So, this is sort of like the baseline reality out there, and these bars are just the cost of a system that makes 30 kilowatt hours a day, which is you have to make an assumption about the sun zone, but in a general sort of like standard sun zone in Hawaii, that's about 6.7 kilowatts DC, and at $4 a watt, that costs $26,000. If you get down to $1.50 a watt, which is the DOE Sunshot goal, it's about $10,000. So this or something like this is what's happening and is what is going to continue to happen. So you can, which is, I would say, not a ton of money, whether it's subsidized or not. And everything I'm talking about in this talk, any number is unsubsidized. So if you translate that into cost per kilowatt hour, you're ranging from a little under 10 cents down to a little under 4 cents, which is just really, really, really cheap compared to what people pay for any service class of power in the state for any of the state's utilities. This obviously assumes net metering, and we can talk about that. But I mean, that's the choice that's faced by the customer today. That's the expectation that they have, and that's the expectation that continues to get reinforced by every potential threat and stoppage to NDG and change net metering and on and on and on. It just hasn't happened yet. So this is what the customer is looking at, and this is what drives their decision making. So if you look at this, I got rid of some of those bars just to simplify it a little bit. That's starting on the left is that sunshot amount. And then if you I used MECO's current rate, or roughly MECO's current rate. I start at 29 cents a kilowatt hour and escalate that at 3%, then discount it for at a 5% rate over 25 years, and you get $63,000. On a cash basis, that's $115,000, and we can get into which is the right way to look at this, but I actually think the customer tends to just think of it more on a cash basis. But either way, whether you're looking today or when we get to that sunshot goal, whenever we actually get there, there's a ton of additional money between what it costs to buy a solar system and what it costs to buy the same amount of power from the utility. And here you can throw in the fact that the customer values sort of independence and staking a claim, their psychic value in not buying it from the utility. They don't particularly like the utilities. There's no shock there, but and I'm not taking a position on that. That's just the reality out there. So it doesn't take much, and this is a lot of money, to sort of nudge them in the direction of not wanting to be a utility customer if they don't have to be. So I just kind of did the same, this is repeating the same thing basically to try to emphasize. The point is that on the, I don't know if it's left or right, on the left side, if you take it on a discounted present value basis, on the right side, if you take it on a cash basis, you can buy the PV system and you still have a lot of money left over. And if the customer is thinking about it on a cash basis, it's just, there's no contest. Just focus on that one most extreme of these pies. Are they, okay, I wait a few years and I gotta buy this PV system. I probably gotta buy some batteries. I'm not sure how much those cost, but they don't cost $105,000. It just, this is already asked and answered, and the policymaking process needs to move beyond what are we gonna do about DG, this type of thing. It's just, or is it gonna happen, and can we hold it back, and how should we work to slow it down? So this is my point, is that the choice that the customer faces here, they're not even thinking about the utility power anymore unless they're forced to, because they're a business in a high-rise, they're living in a high-rise condo, this type of thing. Somehow they're a renter, they're somehow constrained to being forced to buy power from the utility. Otherwise, they're just not, they're planning not to do it if they haven't already stopped doing it. And again, I'm not trying to say this is good or this is bad, but I'm trying to emphasize this just is, and it needs to, this fact, this reality needs to be absorbed immediately into the policy-making process. And so my argument here is this is basically the range of options the customer considered. And so, I make up this number. Let's say I need 3 days of storage on this is the same customer, 90 kilowatt hours at $500 a kilowatt hour for the storage. They're spending $72,000. Again, all of this is unsubsidized, so that's kind of like their worst case scenario. And depending on what they have to pay for the PV system, they're somewhere between that and, currently maybe 7, 8 cents, maybe closer to 10 cents, but going down all the time. So this is what they're looking at. They're not considering that bottom option there. And then this is the same thing, just throwing in some, current Arizona pricing for PV. You can already go get this. If you think about how a market develops, it's not going to be the person in the back of the valley with the rainy environment. It's going to be the people in the best sun zone that go for this option first. That's my second sort of red line there. This is $4 a watt in a better sun zone than the kind of standard sun zone, but it's really the same continuum. So. This is sort of my summary here, is that this combination of PV and storage has already won. The reason you don't see it all over the place is because it still has to compete with net metered PV, which is free PV and free storage, which is better than PV plus storage, which itself is better than PV plus, better than paying for the utility's power for 20 years. And then this is, again, it's not a critique of the utility, and it's not saying that there's anything great about the solar industry. It's just that this is the reality out there. So all of this policy energy that's devoted to trying to micromanage DG, it's just wasted. It's like this thing is happening, and we need to assume that, figure out what the portion of the load is that this thing is going to cream off and when, and figure out how to not have that happen if you want the load as a resource to devote to all of these sort of more socially beneficial and egalitarian kind of solutions, which nobody in the solar industry is opposed to. So, there's absolutely a sense in the policymaking community, and not universally, but definitely not among the public, of this demonizing distributed generation, and it's totally misplaced. It's not productive, it doesn't match up with what the public is thinking, and it holds back this process of just getting on with it, saying, okay, assuming that whatever, 25, 35% of the customers are sometime soon, if they don't already, going to have the option to go off their grid, how do we keep them on? How do we turn the tables and deploy these investments that customers are already making and clearly very willing to make and economically incentivized to make, to provide the things that the grid currently provides, and the frequency and voltage regulation and on and on and on. So the point of all this is that we need to get on with the time of use rates. We need to get on with having non-export options, and people will go and invest in this stuff on their own, and we'll just get going. But if we wait much longer, which seems to be the plan, it's going to be too late, and we're just losing chunks of the load all the time. So just to kind of wrap up, I was talking to a solar contractor yesterday who's Oahu-based, who does residential, and it came up that he said, I have 25 customers that no matter what I do, I can't talk them out of going off grid. And that's what the reality is out there. The solar contractors are constantly having these conversations like, you should wait, it's not a good idea, this kind of thing, but the customers want it already anyway. So hopefully my point is clear. We need to absorb this insight and get on with the relevant policy making, and stop trying to do the thing that we continue to do, where it's like, let's figure out how to slow DG down and this type of thing. It's not going to slow down. It's doing its thing, and we need to orient to that. Thank you.
Interestingly enough, Mark, I think earlier this morning and throughout the conference, we've heard the same recurring theme. Let's get on with it, and let's get business going, and give the customer the flexibility to deal with their energy needs as well as expand their choices. Now, as we all know, growth has been tremendous in the rooftop PV industry. And partially it's been driven by the fact that here on Maui, here on Hawaii, rates are high. They're the highest in the country. Maybe not Alaska, but they're pretty darn high. And because of that, the utility has been faced with some very, very unique challenges. They have some opportunities. They have to deal with managing the grid. And it's not an easy task by no stretch of the imagination. But as we've heard earlier, it can be done. And Matt is here. He's been in the forefront of the renewable energy development here on Maui for Maui Electric. And he's dealing day to day with some of these issues and challenges. Matt?
Thanks, Bash. Okay, again, I'm Matt McNeff. I'm the manager of the engineering department at Maui Electric. I'm going to give a brief overview of the current state of distributed generation and summarize some of the Hawaiian Electric Company's proposals to sustainably increase that generation and try to change the offerings that we can provide customers. We're seeing the same thing that Mark just talked about, and we're actively coming up with proposals to try to meet their needs. So first, you've heard it a few times, but the Hawaiian Electric Companies are leaders currently in the nation for solar, and solar is the most prevalent type of distributed generation in Hawaii. In fact, Hawaii has close to 4 times the solar penetration as a state with the next highest penetration per capita, Arizona. For the Hawaiian Electric Companies, that means about 12% of our customers currently have solar, with a combined total of nearly 400 megawatts across 5 islands. A little closer to home, for Maui Electric in particular, that means 7,000 customers in total have solar, with a combined total of 47 megawatts. And I'd like to note that at 47 megawatts, solar is larger by a significant margin than any generator Maui Electric owns. And last year, just to talk to some of the slowdown issues, we interconnected more customers and more PV capacity under the net energy metering program than we had in any year previous. So recently, we filed our proposed plan with the Public Utilities Commission, which is still under review and subject to their approval, on how to continue to increase solar in a fair and sustainable manner. The net energy metering program has been brought up a few times, but it was created in a time when solar could not compete on its own. And times have changed, and we believe our programs need to do the same. We're proposing to transition to a more sustainable program that will support continued growth in rooftop solar in a way that's fair to all customers. Currently, the cost of grid operations and maintenance is increasingly being shifted from those who have rooftop solar to those who don't under the net energy metering program. And at the end of 2014, that cost shift was estimated to be about $52 million, up approximately $15 million from the year prior in 2013 when it was about $38 million. So one important point about what we're proposing is that all customers with NEM agreements in place and those that have already applied at the time of the transition would not be affected by our proposed plans. We intend to honor all the agreements that we have signed, and anyone that has applied to be in the net energy metering program, whenever we eventually move to something that's more sustainable, would be honored. We have already increased the circuit penetrations that we use for screening interconnections for overvoltage issues from 120% up to 250% of the daytime minimum load. It was mentioned earlier in the day, but these technical solutions were developed in partnership with the National Renewable Energy Laboratory, Solar City, and the Electric Power Institute. One good thing about being on the forefront of solar penetrations, as you heard Eric say earlier, is that it allows us the opportunity to work collaboratively with different industry partners to really come up with innovative solutions that will be able to be applied in markets around the United States and elsewhere. To further support even more customers adding solar, we intend to do several pilot projects for non-export or smart export battery systems with local and national PV companies in Hawaii. So this is trying to address some of the battery issues that Mark mentioned previously. And this would provide real-world operational experience on their capability to increase solar penetrations on high penetration circuits. We're also proposing to work with the solar industry to prioritize upgrades necessary to increase solar penetrations. And one of our big efforts is in trying to develop more choices for customers, such as a community solar program. And that would make solar available to those that may not be able to install rooftop solar currently, such as those that live in an apartment or condo. Historically, when a customer triggered the need for upgrades on our system because of a proposed solar system, the cost of those upgrades would be paid for by that customer. What we're currently proposing, in conjunction with our move to a more sustainable program, is that upgrade costs will be treated as grid improvements, benefiting and paid for by all customers. With all that being said, there are still challenges when it comes to system-level impacts. So this graph depicts the electrical usage on the island of Molokai over the day. So the graph covers a 24-hour period, and in particular, this day was January 5th, 2014. The electrical usage, or how much electricity people are using throughout the day, is shown as the black line. The blue shaded area at the bottom is the minimum generation we need to operate reliably. And the purple shaded area above that represents generation that's used to adjust for changes in electrical usage. Against this black backdrop, I plotted 75%, or 3/4 of the solar that has been installed or been approved to be installed since January 5th. And that's shown in the red dashed line on the graph. And it's shown as a reduction in the usage. You can see that the projected minimum usage falls below the minimum generation that we need to reliably operate. So this graph just depicts one of the challenges we are currently still working on, a system level challenge, basically what to do when the generation exceeds the electricity that people are using at the time. You know, overall, our vision, as we laid out in several plans last year, and then you heard at the beginning of today's conference, is to offer customers more choices while increasing clean energy and lowering bills. You know, I sat through today's presentation and I heard a lot of discussion and differing opinions on the details and how to get to the future. But one thing that is encouraging to me is there's a lot of agreement on where we need to go. Thanks.
Thanks, Matt. You know, what's really interesting in all of this is that when Matt talks about the growth and the amount of megawatts that rooftop solar or DG solar represents, the projections are going to be something like 900 megawatts for the entire Hawaii grid by 2030. I mean, you stop and think about 900 megawatts. That's 100 megawatts short of the largest nuclear plant that is operational on the mainland. It's about 100 megawatts, 200 megawatts short of the largest coal plant that is operational on the mainland. So we're seeing a tremendous transformation of tremendous megawatts in small chunks to integrate on a very sophisticated, limited island utility. So it's very interesting how we make this transition. And part of that transition, Mark introduced the concept of battery storage. Battery storage is here to extend, if you will, customer choice. The price of batteries are coming down and give the opportunity to provide a system resource from a customer perspective. And Dan, I'd like to throw the ball over to you and get your impressions of storage and where you see it going.
Okay. Appreciate being invited, Bash. And let me tell you, when I first got invited, one of the first things I wanted to do was sit down. Being an engineer, you got to look and say, who are the key players in distributed generation? And actually, if you look at it, it's really two players. It's the utility and the consumer. So I sat down and went through and said, okay, let's look at it from both sides. What are the concerns of both sides? If you actually look, the utility concern usually are a couple. You got reverse power flow, you got over voltage concerns because of distribution, you got stability of an island. So you got the island, you got certain areas, or you got the whole island having stability issues. And then, of course, the increase for the utility to build the infrastructure resulting from greater renewable energy penetration. Now, if you look at it from the other side, the consumer side, what's the best mechanism to compensate for residential generation? Getting online with the major push for PV. Ability to stay online after a system event. So if there's a power outage, can I stay online without the utility? And then, of course, controlling my own generation power. When do I use what my system produces? So here's a little of an example of a couple systems that are out there in the world today. It'll show basically on the left-hand side is a system for residential. This is owned basically in the utility side, and the right-hand side is a larger, so like you got a consumer type application. When you look at it, can energy storage solve this, and where does this belong? Does it belong on the utility side, or does it belong on the consumer side? And there's a lot of opinions out there as to where it belongs. A lot of it has to do with the closer you are to, I'm going to call it an offending event, but an offending issue, which is distributed generation for utility grid, the more you can handle the situation. So if you put energy storage close to where PV on rooftops exist, the more you can help to solve the issue. With that, again, looking at both sides, Does it belong on the utility side, or does it belong on the consumer side? If I look at it from a utility, utilities can solve a number of problems with a fleet of deployed energy storage units. So if you deployed a number of units, you could solve a lot of the issues. Reverse power flow can become a concern of the past because generated energy during the day can be kept near the area it was generated, resulting in less losses, and put back in the system during the evening or when the photovoltaics are offline. Power factor control, which is normally done by capacitor banks, can be done at these devices if a 4-quadrant controller is used. No need for additional capacitor controls or power factor correction. It can all be done in a single device. Power smoothing can occur. Frequency regulation can be done if the fleet of devices are used. If deployed right and controlled right, units can be used as an uninterruptible power supply. So if your power goes out, and if you have these in the right location, you could bring most consumers back online. At the same point in time, they would remain on with their PV. And there's a case in Southern California where one of these devices kept 4 homes up and running for 4 days. Basically, by having a device, the utility had an outage, customers stayed on for 4 days, they didn't even know their neighbors were out of power. Voltage control is easier. If you actually look at traditional voltage control for utilities, it comes from the substation out, and if you end up with a large concentration of PV, you will end up with high rises or basically voltage increases that are unanticipated. If you have energy storage, you basically use it as a shock absorber to bring the energy, basically act as load or act as basically an energy source when needed. Grid stability can be gained and achieved with a great amount of distributed generation deployed. Now, if I look at it from the consumer side, can solve some of their own issues. If lack of net metering exists, I can store my own energy, and the system generated during the day can be used in off hours. I can have my own microgrid where I can have electricity during the outage or in time of need. I can completely island off away from the utility if I desire. I can be more green in my consumption. So actually, here's a couple of the devices that I'm talking about. Up on top is basically a utility control system, and then you've got like a 25 kVA and a 250 kVA that I mentioned earlier. At the same point in time, what do I need in order for a system to work correctly? You know, for a 25 kVA community energy storage with substation control and with layered intelligence can control up to 1,000 devices, so 25 MVA. A major amount of PV on the rooftop. I think, Matt, you said 47 megawatts currently? So with 1,000 units, you could control up to 25 megawatts of each one. At the same time, if a 250 is employed, along with that, you really have a very robust system. You have a system where you can have substation level control with layer intelligence. You really have a system that's beyond most. System that I have pulled up in front of you here is actually from EPB. I recently was at a energy storage conference, and if you want to go to energy storage conference, they occur about every week back on the mainland. You can go to 100 of these things. It seems like I'm at most of them. But what I brought up was EPB, which is the utility for Chattanooga, Tennessee. This is a one line. If you actually go online, you'll see that they have a system that deploys up to about 1,200 switches. Now, replace those switches with energy storage, and you can control a lot of the PV that's out there, and you can use it at the right times. With this, I was at the event. I mentioned the event. I was at the event, and there's a gentleman who says, utilities cannot control this. Now, there's been smart grid conversation all day so far, and a lot of what we've talked about in smart grid, or what I've listened to, has been about metering and backside. I'm really talking about the operation side for like Matt's system. So out in the operation side, if you can control devices from the utility side, there's a lot you can do with those. Now, I didn't mention my company, so why does S&C have anything to say about energy storage? S&C is installed around, I don't know, 20% worldwide. We've installed about 52% of the energy storage in North America. So a lot of the folks I work with have a lot of background in energy storage. We do think energy storage is the way for renewables to actually come out in the system. And there's been talk, can you reach 80%? Actually, with energy storage properly placed, you could reach up to 100% world. Basically, on the island, you could reach up to 100%.
Good afternoon. So Bash sent me an email, and he, had the general topic here of growth of distribution, good or bad for the customer, and clearly there's going to be a lot of debate on that all day long. And he gave me kind of instructions, to define, tell people what a microgrid was, and there's been a lot of discussion along the way, how it can help to increase penetration of distributed energy, and then also, what HNEI is doing. And in a couple of slides, I tried to take him, literally in that and do it. And so I apologize if I'm offending anyone by going back to real basics, but, I kind of thought, let's at least set the stage, because you hear smart grids and microgrids, and it means something really different to everybody all along the way. So, I went to, the DOE sites and Wikipedia. It's always a good place to go, and a number of other sites. And, basically there's some really common definitions. And so for microgrids, basically it comes up with a group of interconnected loads and distributed energy resources, and it can be anything, often it's renewable, that acts as a single controllable entity and can operate in both grid-connected or island mode. And we heard discussions of microgrids today, but there's nothing in that says they're smart. There's nothing that says they really have a lot of advanced functionality. They clearly have to have a good controller. You've got to manage integrated resources. They can contribute. The key is they really can be disconnected from the grid so they can provide that additional security. So they do have benefits by themselves. If you go to smart grids, you're really now building in the intelligence. And a smart grid can be part of a larger smart grid or a larger grid like down in Maui or on Oahu, or it could be a microgrid, and that could be the part. So, but in this case, you're using two-way information. And we just heard from Dan that a lot of the discussion of smart grids has been smart meters detecting faults, even being able to anticipate faults, enabling some flexible rate structures, because what's going on more accurately with higher fidelity at the grid systems. But what's really developing, and I think where the real value is building in these higher functionality. And it's what the utility is moving for. It's what a lot of the technology developers, Tad talked about as storage, all of that's built into how do you manage these integrated and distributed resources. And some of the things you want to do is you really want to maximize the system efficiency. You want to improve power flow, and that can include going both ways. It does give the opportunity to reduce peak demand. I think one of the other parts of the definition, I missed it, is it allows you to act on this information in an automated way. So you really want to build systems that manage and run very effectively without a lot of utility intervention. It enables these flexible rate structures, and if done right, I think it does increase sustainability and in terms of the ability to put additional renewable generation on. And so I kind of show one slide here, and Matt showed something similar, and I didn't know he was showing it. But as part of HNEI's work, we've been kind of going back through some of the renewable portfolio standards and running a number of scenarios, looking at a potential future utility. It's been somewhat Oahu-centric, but that's because Oahu is about 70% of all Hawaii's energy use, so it's a reason to have some focus on Hawaii. And we looked at a number of different levels of wind and solar, along with some firm renewable in the system. And we took into account that the utilities already making some really substantial changes. A number are implemented on Maui already have big changes, reducing the minimum runs of some of the must-run units, providing ancillary service from solar and wind, increasing the ability of the units to cycle. These things take capital investment, but they provide big benefits. So, I don't run through all these scenarios, but this graph is really kind of looking out a few years. It's saying, let's look at a fairly high it looked like a fairly high penetration of renewables until the recent discussion. but it still sounds like a lot. So it's Oahu, 200 megawatts of wind. Maybe we will get there, maybe we won't. Seems to be more focus on solar. It assumed 460 megawatts of distributed PV and 400 megawatts of central. And the shape of that curve is not going to be very different, except your controllability is going to be a little different if it's all distributed. So, you know, the top curve there is the load projected out to kind of the time frame when this would occur, about 2020. And what you see is you know, kind of what we think are our best projection. And this is a week in March. It turned out to be, you know, after a lot of statistical variability, a fairly high penetration week of the renewables just because of the randomness of the model that was used. But it shows a couple of classic characteristics. It shows that there's a very steep drop-off in the morning as the PV comes on. There's a very steep ramp in the afternoon. We do get below, in this particular week, what we call the minimum, minimum planned generation, or the minimum load from the conventional units that includes both, the minimum of those values and the reserve requirements. There are some, so you look at that and you think, okay, we're facing a lot of issues. There are some positive things from this. If you look at that penetration level, that's about 3 times, well, okay, back up a little bit. This is assuming no real major changes in utility other than what is planned and underway today. So it doesn't involve large amounts of storage to get to this point. It doesn't involve smart grids. Doesn't involve any technology that's not really readily available. So one of the conclusions is we really can expand substantially the amount of solar that we have and still be pretty well off in terms of the system level security and reliability of the system. With the increase by the utility to the 250% of minimum load, daytime load for the circuit side, it looks like there's a good opportunity for substantial increased growth without invoking lots of other things along the way. But issues are beginning to show. You know, that those ramp rates, particularly in the afternoon, you know, you can kind of look at it and say, well, why can't I turn off other units and go down lower? Well, if you do that, and these are looking at existing units and upgrades of those units, you can't ramp up fast enough to meet that evening peak. So yes, storage can start to make an impact, but we need to maintain reliability during that period of time. At that minimum load of the system in the middle of the day, the maximum PV, you have potential of dynamics response. If a unit goes down, the unit is very susceptible to reliability issues. Storage, again, can start to play a role in that. The reliability at that peak in the evening is a significant issue. There's, you know, the generation or mechanical systems, sometimes they're on outages because of maintenance, and sometimes they just go out because they randomly have issues. You have to have enough backup during that period of time. So again, it puts somewhat of a limit on what the utility has to keep operational at that time. So we're starting to get to a point where, you know, at this level, you can't push the system too much further. If you do the math, those numbers are big. 460 megawatts of distributed, 400 megawatts of central. That really is only about 26% of Oahu's power from intermittent renewable sources. So if we want to push these numbers a lot higher, we really need to bring additional things into play. So, you know, I don't have a suite of solutions, but really that's where the smart grid technologies start to come into play. So there's pricing issues we can deal with, and people have discussed it very eloquently during the day. Time of use rates to start to flatten this curve. Technology, battery energy storage, could be central, could be on the circuit, depending on what you're trying to do for these different applications. Electric vehicles can play a role, but only if you're going to start to charge them in the middle of the day. If you're going home and plugging in at night, you're going to exacerbate these issues. Advanced inverters with greater functionality are starting to be developed or are being developed. Some are being deployed. HNI is starting to deploy some in collaboration with utility, but they're not really operational as a tool yet on the grid. And then finally, one of the things that hasn't really been discussed a whole lot today, but with a smart grid and with its functionality, you can do a lot more with distributed demand response to try to shave that peak at the end if you need to. So, lots of potential solutions related to smart grids, but lots that we need to do. So, from the H&I perspective, we've established a group. We've called it Grid Start. Kind of be looked at positively and negatively depending on your point of view, but we've got some 80-plus years of combined utility and regulatory experience in that group. It gives us a group that has the experience with the utility, knows what the utility needs, knows what the issues are, but is really looking to how to push this technology further. Although my previous slide was on Oahu, a lot of the projects we're actually running in terms of these smart grids and microgrid projects are over here on Maui. So we had a Maui Smart Grid project starting about 2009. It ended about 6 or 9 months ago. Was looking at integration of demand response and peak load reduction using advanced controls and metering. Jump Smart Maui started sometime after that, a couple years after that. H&I has been integrated into that. Those projects have joint players. The Jump Smart Maui took another step further and looked much more intimately at storage and electric vehicles as a tool for managing those peak demands and energy flows. H&I then received funding from the Department of Energy for a Maui Advanced Solar Initiative. This one was looking at very advanced inverter functions to try to bring that into the grid on Maui. And then there's the Jump Smart Maui Phase 2 that hopefully will take off in the future. This slide is very busy. I think I've overgone my time, so I'm not going to talk too much about it. But we are in the process of deploying these advanced inverters on a circuit in Kihei. These inverters can communicate back to the smart meters. The smart meters can get commands from the distribution management systems or energy management systems, and then looking at providing direct functionality back there at the circuit level, all part of how do we manage those energy curves to allow us to get more energy back onto the grid. And I had a closing slide, but I'm not going to talk about it, so I'm finished. Thank you.
Thank you. Hey, Rick, you guys at HNEI are the premier investigatory and research group. But microgrids, you're doing a lot of work on microgrids, but why haven't we really adopted them as part of a utility strategy? What's going on? Are we on the cusp, or what's happening?
So do we want it to be microgrids or smart grids?
Microgrids. Let's talk microgrids.
With the definitions I put up there, microgrids provide additional secure energy reliability and security for a subset of the utility sector. It can, if it's operated properly, help enhance that interface with the grid and potentially benefit, the ability to put more renewables on. But by itself, it doesn't really have the functionality you're really looking for to increase the renewables substantially. So I think it's really a combination of microgrids and smart grid functionality the utility has to go to. The problem, and it's not so much the problem, but in regard, and Dan may have an opinion on this, but in regard to the smart grid type functionality, it really is just now evolving. The Jump Smart Maui project has invested some $35 million here on Maui. It's really looking, in some ways at a limited scope. It's looking at EVs and some battery storage to manage peak demand and curtailed power. That's one piece of a much bigger picture. So I think it's partly that the technology is evolving, the hardware is evolving, the technology companies that we've heard from are all going to contribute to it, but it's not yet integrated into easy-to-use packages for the utility. So it's going to be companies like S&C and developers that will put that together, and then the utility will adopt it.
Great, okay. Dan?
Yeah, I'd like to add something on that. I think what Rick says is very true. I think what you need is distributed, basically, intelligence, which basically is microgrid type applications. And then what you need is an overriding intelligence, which is basically driving what's the system doing and how you're going to control that overall. So when you talk microgrids, microgrids has really come out. Actually, we've built microgrids since the 40s, if you actually look at it. It was usually the hospital with the auto changeover and the generator. Now we call them microgrids. But they do have a big amount of future for as you deploy more and more renewables.
Good, thank you. Hey, Mark, we talked a little bit about, during the course of the conference here, other speakers have introduced I think alluded to the business model of the utility, of maybe getting involved with their customers and providing energy solutions to their customers. How do you feel about, say, being the installer of PV systems for customers at the benefit of the utility, i.e. the utility hires you to install systems for them?
Yeah, I mean, it's hard to answer because it's so far away from where we are now. I mean,
Okay.
I feel like there's a lot of understanding that would need to go on their side to get to the point where they were specifying even potentially systems that customers were interested in. Obviously, those would ultimately, whatever that value proposition looked like, would ultimately be competing with at a minimum, going off-grid. And I think there's a long way between here and there. But in general, I mean, surely there's that whole policy level, but separately, you're sort of implicitly asking a contracting question, which is, would I rather respond to a utility RFP to compete, for a giant chunk of very low margin business with a zillion other contractors, or with a handful of very large prime contractors who might then hire me as a subcontractor? It's not compelling at all. But I don't think it's a really, it's not a proximate concern of mine either. I think we're a ways away from that.
Good. Well,
Even if it could be determined to be in the public interest, et cetera.
It was like it was brought up this morning, the idea of maybe the utility is providing for the customer's needs, i.e. doing the providing the panels and the systems for the customer, basically for a way of changing their business model that maybe they can make some money. So, Matt, any comment?
Well, I think we are heading down that road in a way with some of our community solar programs that we're currently
there you
proposing.
go.
I mean, it's not envisioned to be on people's roofs, but it is going to have some of the benefits of a large central station, and give us controllability and a lot more of the functionality that can be built into a large system, and at the same time customers can get the benefit of that solar.
Very good. In follow-up, Matt, from a utilities perspective, is there an optimal mix of distributed DG versus distributed renewable resources versus utility scale resources? Is there an optimal, in other words, I got too much of DG, I can't control it, but I need to balance it with something else. Is there an end point, or are we totally going to be distributed in the next 10 years?
I think there is an optimal mix. It probably varies by island, and I'm not sure what it is. I think right now distributed generation is sort of leading the way, and some of the centralized production needs to catch up.
Good, thank you. We've got some tremendous questions here. I'm not sure we're going to be able to get through all of them, but let's try this. To all members of the panel, what will it take for residential scale storage systems to be incentivized by state and the feds, similarly to how PV how PV is currently handled?
Well, I mean, we can maybe all comment on that, but on the federal side, it's clear the same incentive exists, so I think there's no barrier there. On the state side, it's a little bit grayer, but I think historically, at least, the tax department has approved PV systems and potentially other types of DG that have storage embedded with it for the credit under whatever the then applicable rules are. So, but I mean, more sort of interestingly, to kind of mine this question, the issue is not incentive for the most part, it's regulatory. I mean, Hawaii has fabulous fundamentals for storage. I think that's clear to everybody, including the many storage providers and the, attending this conference. But where that market actually lands is totally up in the air. I mean, from whether it's going to be utility owned and sited down to fully off grid, if that's the continuum, and you could have all of those different outcomes depending on what happens in the half dozen regulatory proceedings that are ongoing that touch on this in one way or the other. And so I think that's what the state is waiting for. And, to sort of further put a point on this, if you wanted to see storage start getting deployed, all you would have to do is establish a path to operation in parallel for non-exporting PV, and customers would optimally invest in it on their own already. It's pretty simple. And then once you added to that time of use rates and potentially payment for ancillary services and demand response and everything else, you just would layer onto that. So that's the type of market solution that we need.
Matt, any comment?
Sure, I can't really speak to the state and federal incentives, but I can say the Hawaiian Electric utilities are working on programs that would incentivize customers in exchange for some of the benefits to the grid that this distributed batteries can provide, or distributed storage. So in our own way, coming up with programs that sort of incentivize customers to go that route, and then in exchange for grid benefits, pay the customer essentially.
Right, good. However, does the expiration of the Fed ITC in the end of 2016 affect the residential market?
It definitely does.
So,
I mean,
that's been factored in the overall marketing and so forth.
Well, I mean, it's just going to borrow from future demand. How far into the future it goes, this isn't clear, but I mean, 2017 will be a challenging year if nothing changes, for sure.
Any other comment? Okay. Matt, here's an interesting one. It's regarding the 250%. Somebody wants to get interconnected here. You mentioned an increase to 250% of the daytime minimum load for distributed PV systems. Is this the screen being used for all customers, island-wide, MECO, HECO, HELCO, for all customers?
The 250% that I mentioned, the daytime minimum load, is the screen that's currently being used for the transient overvoltage issue. That's not the only issue that we check for, but in the past, people have focused on the 120% that we previously used, and we've moved that up to 250% recently.
Okay. This is addressed to the entire panel. Since last year's energy conference, have any of the DG challenges for Maui been addressed, improved, or restating the problems with no progress toward real solutions for Maui? I guess the way I would interpret that is the fact that we've got a queue of a lot of customers. There's statewide, there's well over 2,000 customers waiting to be interconnected, and the goal is to clear that queue by April, or the majority of that queue by April of this year. Where do we stand on that? Are we making progress? Are we nearly done? Because it's the end of March and April's coming, so.
Sure. Yeah, we're definitely making progress on that. In fact, for Maui Electric, we've already cleared that queue. And as I mentioned in my presentation in 2014, to talk about some of the benefits that have been had, we interconnected more customers with a combined total of more capacity than we ever have in any year prior. So definitely progress is being made, and customers are taking advantage of the benefits that solar provides.
Okay. To Mark, are you saying PV customers should be required to install batteries to help in reducing their, to help and reduce upgrades, system upgrades?
What I guess I definitely didn't say that. What I said is that if you made rules, that if you look at this as a market and look for market-based solutions, if that's what you want, then you need to make rules that encourage customers to do that, as opposed to taking that kind of brute force or brute force approach. So if you are rationing interconnection opportunities, which has been the case for much of the last 2 years, and you say, well, we'll let you interconnect if you do such and such, including something like that, then you're going to get people starting to do it. And they may not be trying to offset 100% of their load. They'll shift load into the solar window because that's cheap, and they'll install solar water heating systems because they don't want to pay for PV and batteries to heat their water. But then one of the things they'll do, potentially at least, is install some storage to shift some of that cheap solar generation into the evening peak. And then they'll probably continue to pay the utility to run their refrigerator and their cable box and whatever else they run at night. So you just have to start the way that this is what I think is going on is if you look at the Commission's inclinations among other places, you see them talking about the regulatory compact, exists and worked as long as the customer needs the utility. And that's less and less the case over time because there's this alternative. So what's happening is DG is reintroducing microeconomics to this world. And so the solutions that we're deploying have to take account of those consumers' microeconomic motives. And so if they really want to get interconnected because it's in the money or for whatever reason that they want to do it, then you need to detour them through the thing that you want on the way to that interconnection. And you're going to get much quicker to the point that you want to get to than if you just try to say, well, how do we want DG to work? Or what do we want to get out of customers, this type of thing.
Okay. Here's one for Dan. If Hawaii can achieve 100% renewable energy through battery storage, what would this cost the customers?
It's a little bit like PV. When we all look at energy storage right now, it's at the very beginning. And when you look at PV and how fast that has basically ramped down in cost, we're seeing the same thing starting to occur in energy storage. So it's hard to put a cost on it. We did an island investigation for an island in the Caribbean, and to hit 100% becomes very, very costly. To hit 80%, though, is not as costly as hitting 100%. So when you start looking at rotating devices, the big advantage of basically a battery is it could be on in a quarter of a second, which is basically, quarter of a second. It could be on much quicker than that. It'd be on quarter of a cycle. So someone mentioned earlier how quick their electric vehicle is compared to a traditional combustion engine. Same type of thing. You can get that energy on very, very quickly. And cost-wise, I think if you look at all of the benefits, there's more benefits than non-benefits of putting energy storage in. It's going to take a while, though, to get to that point.
Very good. We're just about out of time, and I've got one more question, and I'm not sure the panel, I'm not sure you guys are going to be able to answer, but I think it's a question that's probably very, 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 very germane and certainly food for thought going forward, and it involves transportation. And in my career, I've been involved with the electrification of railroad. And it didn't go forward, but it was a major, major step. And when you look across Europe, there's major electrification of transportation. Here in the United States, there is electrification in the subway transportation infrastructure. There's also the only electrified railroad that I'm aware of in the United States that actually hauls freight is the one from the Navajo coal fields to Page, Arizona. And so here's the question. How much more electrical power would be needed if all the transportation in Hawaii, or Maui for that matter, were electric instead of gasoline and diesel? Interesting question and food for thought. Maybe next year we'll answer that one. Thank you very much for your attendance. Thank you, panel. Appreciate it.